Okay, who are you?
My name's Mike Burrows. I'm a dev lead in the Windows third-party gaming and graphics group.
Cool, and I take it you have something pretty neat to show us today, so...
We do.
All right.
Meltdown today we're showing PIX and the new functionality within PIX, Performance Investigator, on the Windows platform.
Yep.
And particularly tailored towards the graphics pipeline.
Okay.
So one of the things that people have really been asking for more information on is how do we get detail on what DirectX and particularly Direct3D is doing. So what PIX enables us to do is get a level of information back from the graphics stack to the developer.
What does PIX stand for?
The original name was Performance Investigator for Xbox. This is a tool that we originally took the concept from Xbox when we were doing Xbox development work, and we brought it over to the Windows platform.
Okay, so Performance Investigator for Windows. Sweet. Let's see a demo.
Okay, so if I just open the icon, I've just copied this on the desktop. It's included as part of the DirectX SDK, but for the moment, just for convenience, I'll launch it off the desktop. You start off with just a basic windowed view as you'd expect, and you have this concept of experiments. And experiments are different tasks that you can perform upon an application. So in this case, we're going to actually use Zoo Tycoon 2 from Microsoft Game Studios and do some initial capture of the data.
Okay.
So I've already plugged in the namely executable, and one of the simplest things I could do is say type in the address of where I want to save what we call a complete call stream. So this captures every piece of data from the Direct3D API in the stream and puts it onto the hard drive. So let's just, I don't know, call it ZT2. Okay. I was going to say Z then for a moment. Full stream capture, that's what we call it, and PIX run file. And it's as simple as that to get started. Now what that will do is launch the application, and this is just a retail application that I've just pulled off the shelf, and I'm just playing the game as I would play the game. But if you notice in the top left hand corner of the screen here, there's some information coming from PIX saying it's capturing data here, like what frame number, how much data it is. As you see, that's going up quite a bit, so let's get into the game. So now this is loading the actual game itself, exactly as you'd expect, and then once we get into the game, we can do something more interesting. One moment.
Will this work with any game?
Any DirectX, Direct3D game, Direct3D 9 and above. So what I'm just going to do is some simple things. I'm not a great Zoo Tycoon player, to be honest, but I'm just going to create some bears, a representative scene of what I would generally be doing within the game.
Okay.
And then I'd let that run for a few seconds. So now I'm getting an idea of what's actually happening in the graphics stack for this title. So once I've got a representative sample, I then come out of the title itself.
Okay.
And that's stored off to disk. At its most basic level, I can just play back that data stream. So if I go File, Playback Stream, and pick the stream that I just saved, this one here. So now I'm not actually playing the game. This is just a stream being played back. I can show you that I can go straight into wireframe.
Neat.
I can pause the game. I could single step through the frames. But for this, I'm just going to let it play back. But that's one aspect of it. But what this allows you to do is get a good reproducible sample stream back. So one of the big areas developers had difficulty with is having a deterministic graphics output, because obviously when you're doing profiling you want to make sure that you can measure the delta, the difference between your performance profiling before you started and afterwards, so you can determine if you're making good progress or not. So this allows us to concentrate on the graphics part and aspect. What we can do as well, sorry I just killed that out, what we can do as well is get a lot more information about what's happening with Direct3D as well. The stream that we just had, rather than just playing it back, we can do a lot more manipulation on it. So if I open the stream within the tool, this is going to take a few seconds, unfortunately. But if I just open it in, it's optimizing the file currently, so it's easier to view each frame as it's happening. But what we can do now is look at every operation that happened within the title itself and get a level of detail. Again, we've recorded all the state information, so we know exactly how many D2D devices there, the state of that D2D device for every kind of draw call, every D2D operation that happens. We know the resources associated with those. We can view the resources and objects and everything else like this. It's really cool.
It's really cool.
And it's just a case that we've never really had a way to get this information out to developers previously, and so we're all very excited about it. So it's just about to finish the optimization process.
Okie doke.
So as well as playing back that stream, like I said, just increase the size of that window. We have basically, if you look, each one of these frames here is as it was rendered within the program. So if I just pick a frame, I'll actually pick something a bit further on. Otherwise, we'll probably just get some of the loading stuff. You can see here we have, like, you know, this is a Direct 3D device. It's doing a test co-op level at the start of every frame, which you'd expect, you know, pretty sane things. And what this allows us to do is make sure that what the developer was actually trying to achieve talking to the D2D API is actually what's occurring. Quite often with a level of abstraction, particularly with, like, you know, these new high-level languages, people kind of get slightly too abstracted from what's actually going down to the metal, and this causes some performance concerns. Nobody really knew where the delta was. You know, if you're talking multi-million lines of code now in a modern-day game, it's very easy to, you know, lose track of what is actually happening down at the API and device level. So you can see all the various actions here. We can also sorry, the screen's pretty small here.
No worries.
This is the best reason for a 21-inch monitor you can imagine.
Oh yeah.
We can also render the frame itself, so I can tell that's a bit squished. If I scale it to 100%. So this is actually, you know, for that frame, this is what's occurring. There is a concept of a single frame capture. I can show you that as well.
Okay.
So we have the whole stream here. One of the things we have to be aware of is with D3D, we have to record everything from the start of the application run. But even at this level, I can, you know, get information on, like, what was this texture. So I double click on the texture, and in the resource viewer, that was the actual texture represented by this pointer. It could be a texture, it could be a vertex buffer, it can be any of these resource types here. So pretty much, you know, if I just like to see what textures were used within the application, I can just sort by that, and I can look at the different textures that they have within the application. So there's one. And this is, again, a level of information that we've never really been able to expose to developers before. So if I just close this a moment, and I can start another experiment. If I move into the more options or advanced view, instead of just using these counters, I can do what we call a single frame capture. So what this does is it sorry, I've got to think for myself, I'm doing this on the fly. So I'm just going to create a run file, same type of idea, so I'll call it ZT2 single frame capture.pix run. So it's, again, you know, pretty similar concept. But I'm also going to add at some frame, and this would be something you determine from the performance analysis. You know, this is one frame that I want to go have a much deeper look at. So say, I don't know, it's frame 800, and I want to take a full snapshot of the device at that time. So I change, like, call capture, and I say, you know, get me a full single frame capture. Maybe I want to capture D3DX as well, one of the extensions to D3D. And again, I can just run that experiment. So that's going to run the real application once more. So again, skipping straight into it, getting in as fast as we can. And so Savannah, and joining the game. The magic number is going to be 800, so the frame counter, as you can see, is going up.
Yep.
And so we really need to try and get something interesting to make this a good frame for you. So let's just, again,
Fingers crossed.
Put some bears out. And turn those off, zoom in, maybe rotate around, zoom in a little bit more, frame 650, we're going to get there.
We're getting there.
Oh, there you go. If you notice, the size of the file is currently 0, and it just, I don't know, did that capture? We'll check that. I may have messed that up slightly. I'm just trying to figure out what happened there. Oh, sorry, I thought I typed in the name correctly. I must have mistyped the name. Sorry about that.
No worries.
Always good doing live demos. Single frame capture that picture. That's it.
Okay, so while this is doing its thing, is this something that folks can start using today?
Yeah, as it would happen, we've just released the August DirectX SDK, and that's containing even more advanced functionality. So one of the areas I'm going to show you now, the object viewer and resource viewer, that's distinctly enhanced in the August release, which was released today.
Oh, cool.
And it's one of those areas that's given us much more flexibility. With DirectX releasing every 2 months now on the SDK, it's given us a lot more opportunity for us to be responsive to what customers want. And a lot of this, you know, I want to be clear, is based upon customer feedback.
Right.
It's really based upon customer feedback. A lot of people say that, but the amount of people who help us, giving us ideas and, you know, ways of trying to use the tool that we hadn't anticipated is amazing. So we now have this timeline view, and we can see there's one frame of information here. If we look, sorry, in the bottom left with the events viewer, you can see there's about 5,000 events that have been captured. So this is the entire frame
Wow.
self-contained. And again, if I increase the size of this, I can zoom in on the timeline view. Sorry, I'm jumping around on the UI, it must be fun.
No, this is great.
And I can zoom in to the point where I can actually get some timing information, and I can do like a visual scrub, like an audio scrub, but I can build up. Am I outside the frame? I think I'm outside the frame, sorry. But I can build up the scene, draw call by draw call, and I can jump backwards and forwards within this view at the bottom for each draw call. So I can literally single step through the draw calls as they occur, forwards or backwards, and they get visually represented on screen as that draw occurs. In the object view, and this is the thing that's new for August, this gives me a much better idea of what's actually happening within the resources of the game. So, for instance, I mentioned like textures before. I could say, you know, show me all the textures that are alive for this frame and have been used in this frame, sorted by size.
Okay.
This gives me a good way of determining, you know, maybe I'm being less efficient than I could be in my use of resources. So I could literally just double click on there and, like, you know, here's one of the textures being used by the game, the UI. So, you know, I'd be looking at this and saying, you know, there's a reasonable amount of space here, maybe I could do this slightly more optimally. You know, does it need to be at this resolution? And get an instant saving in terms of it. Also allows you to validate the fact that you haven't got duplicate textures. So in this instance, it actually looks like this texture has been loaded twice, but nobody's actually referring to the second one.
That's great.
So there you go.
Well, thank you, Mike, and I hope your presentation goes well.
Thank
Thanks
you.
for talking to us.
Thanks
We'll
for coming.
see you later.
Thank you. Bye-bye.
Starter up. 5 seconds. Counting down.
Oh, okay. Hi. I'm David Weller. I'm the community manager for the Windows Graphics and Gaming Technology Group. And we're here talking to Steve Lacey. And Steve, why don't you tell us a little bit about yourself and just kind of some brief history about your career at Microsoft and before that.
So I guess some of the guys watching Channel 9 will have seen the Flight Sim video we did a while ago. So I'm working on Flight Sim at the moment. I'm the software architect dude and mainly the graphics engine lead. So that's what I kind of do now, and it was really cool because about a month ago the DirectX team came and asked me if I wanted to come talk about Flight Sim Meltdown, about what we're doing with the next version of DirectX, which was kind of cool for me because they've been talking like this is the 10-year anniversary of DirectX, so that's fun, and that's what I used to work on. I used to work at a small 3D startup in the UK called Rendomorphics. I think we were like about 6 people and an admin, and all 6 people. And marketing. So there are 6 developers. 1 woman who's marketing, PR, and everything else that the developers didn't want to do. And 1 admin. It was great. And then in February '95, which was a few months after I joined the company, we got bought by Microsoft. And
Was that completely unexpected?
No. There were at that time 3 effectively 3D API companies that were targeting the games or interactive multimedia or whatever they wanted to call it at the time. The nomenclature at the time was really weird. But games, and they're all doing software rasterizers. There was no 3D hardware unless you were like on a high-end, multi-tens of thousands of dollars box, which you all know all about. Yeah. And so there were 3 companies that did software rasterizers and 3D APIs, and we were all based in the UK, and we were all in London. I'm not sure where Criterion were. I think they were just outside of London. But there was us, Rendomorphics, with our API Reality Lab. There was Argonaut with their API B-Render, and there was Criterion with Renderware. Criterion, everyone knows Renderware now, and now EA owns them. But it was like, you know, it was kind of unsure who was going to be the winner, really. I mean, people were choosing different APIs for different things, and we knew like Microsoft was like kind of sniffing around, and they came and did a sort of evaluation of our stuff, and actually some teams in Microsoft were actually using our stuff. There was the VRML browser that was, I think it was in like IE 2.0, used our stuff. There was a team. Do you remember Talisman?
Vaguely.
Talisman was there was a hardware initiative out of research. They had a 3D. They had a sort of functional API called Appelli. I think it was called Appellis at the time, and they were using our stuff. So we had some good knowledge, some good recognition in Microsoft, I think. But anyway, at the end of the day, they bought us, and that was fun. I was just a developer at that point, so I didn't get to participate in the buyout. So sniff.
Let me ask you a couple questions then about DirectX as it was then. I mean, was it really the case that what RenderMorphix was and what that API was, is it really literally what DirectX was at the beginning?
No.
Or did it change quite a bit?
No, it's changed a lot. I mean, at that point, so we're talking February '95. DirectX 1 hadn't been released yet. It was really called at that point it was called the Games SDK. And it had a few components. There was Direct Draw, Direct Play, and Direct Sound. I'm not sure whether Direct Input was in it at that point. Direct Input may have come later. But basically, I mean, the main foundation was Direct Draw. And the real thing behind DirectX, I mean, DirectX was a skunkworks project, right? I mean, there was two guys, sort of basically, there was Craig Eisler and Eric Engstrom, hiding away in the porting lab, hiding from their bosses, basically making this thing work. They had game developers, no one thought about games on Windows. I mean, what's that all about, right? I mean, everyone was working. It was targeting DOS, and Windows 95 was just about to come out, and I guess needed this massive. I mean, this is my understanding of the situation. We needed a massive push. We needed people off of DOS and onto Windows. And there was limited support for direct access to the hardware in Windows. I mean, the whole point was abstraction, right? There was DispDib and WinG was around. There was the whole V-flat-D driver model, which exposed. I mean, you've got to understand at that point the hardware. There was no 3D hardware. We just had. Literally, it was just 2D hardware, and it was exposed in a bank switch manner so that you could only access, I think it was 640K at the time. I can't remember exactly what it was, but anytime you crossed that boundary, it would cause a page fault, and really bad stuff would happen. So there was no linear access to the memory. There wasn't here's the start of the surface, and here's the start of memory, and here's the end of memory, and you can do whatever you want in the middle. That didn't. You just couldn't do that. And what Direct Draw did and still does, which is just a phenomenal piece of engineering by Craig Eisler, was to expose all these myriad pieces of hardware in a single API fashion, rather than everyone having to write their own driver effectively under DOS. It was